Okay, think way back, way before the Silk Road you usually hear about. We're talking the 3rd millennium BCE. Imagine this huge network connecting southern Arabia, South Asia. Spices, metals, pottery, moving all over the place. But let's unpack this, because maybe it wasn't just goods they were trading.
Right. It's fascinating. This early connection, thousands of years ago, well before what we often think of as early globalization, it probably wasn't just about exchanging objects. It could easily have been a pathway for other things, less tangible things.
Like diseases.
Exactly, like diseases.
And that's really the core of our deep dive for you today. We know you want the essential info quick and clear. We're digging into a new study that's found the earliest signs of leprosy outside South Asia. It's like a window into Bronze Age health, how things spread back then.
Yeah, and our sources for this are an article in Science and the actual research paper from Frontiers in Medicine, both zeroing in on this discovery.
Okay, so the setting. A copper working site up in northern Oman, over 4,000 years old. A busy place.
And it's right there that researchers found these skeletal remains, and they're suggesting leprosy might have spread much earlier and wider than we thought.
So let's picture it. Dahwa, northern Oman, Bronze Age. They're working metal, and it wasn't some isolated village, right? They found Indus Valley pottery. So these an-Nar people, they were definitely trading.
Definitely. And the key finds came from inside two big circular tombs there, monumental
And
structures.
inside, a lot of material to work with.
Oh, yeah. Over 180,000 bone fragments. It was a massive undertaking, which is how Gwen Robbins Schug got involved. She's a bioarchaeologist, studies ancient human remains. And crucially, she'd already identified the previous oldest leprosy cases, first in India, then Pakistan, so she was invited to look at these Omani remains.
Ah, okay, so she had the expertise.
Yeah.
And what did she find in those thousands of fragments at Dahwa?
Well, within all that material, they identified jawbone fragments from 12 different individuals showing signs consistent with leprosy.
12. Wow. And what kind of signs are we talking about? Like, what does leprosy do to the face that you can see in bone?
So the classic signs they look for, especially in the facial skeleton. The bone around the nose might be worn down, the edges of the nasal opening get kind of rounded instead of sharp. Also, the palate, the roof of the mouth, can get pitted or deformed, and you see bone loss where teeth have fallen out, beyond just normal tooth loss.
Okay, those sound like specific markers, but,
Yeah.
I mean, after 4,000 years, how can you be absolutely sure it's leprosy and not just, damage over time?
That's a really important question, and that's where the technology comes in. They took the three most complete jawbones and used microcomputerized tomography, micro-CT.
Micro-CT?
Yeah, it's the super high-resolution 3D imaging. Think of it like a medical CT scan, but way more detailed, down to the microscopic level. And this was actually the first time it's been used specifically to diagnose ancient leprosy like this.
Okay, so what did that level of detail show them?
It let them see inside the bone structure. They could spot damage beneath the surface, patterns of bone reaction and resorption that are really characteristic of leprosy's progression. And crucially, it helped them distinguish these changes from any post-mortem damage, stuff that happened after death.
Right, so it confirmed the visual diagnosis and ruled out other explanations.
Got it.
And the dating. When exactly were these people living?
They used radiocarbon dating, both on charcoal found near the tombs and directly on the bone mineral itself. The dates came back consistently between 2500 and 2000 BCE.
2500 to 2000 BCE. So that firmly makes these the oldest cases found anywhere outside of South Asia.
Absolutely. It's a significant finding for understanding the disease's history.
But 12 individuals at one site. You mentioned earlier, leprosy isn't actually super contagious.
Exactly. That's what surprised the researchers, too. Leprosy transmission is, well, it's inefficient. Only maybe 5% of people exposed to bacteria even get infected. And of that small group, maybe only 20% or so actually develop the disease with clinical signs.
Huh. Those are pretty low odds. So finding 12 people with clear signs.
Yeah, it really suggests that the bacterium, Mycobacterium leprae, might have been, well, more common along these trade routes than you'd expect based on modern transmission rates.
So the trade routes themselves could have been the conduits.
That's the strong implication. It fits with ideas from people like Eric Strayhorn, an environmental historian. He suggested that maybe sailors packed onto boats or merchants traveling these long distances between the Indus Valley and Oman, they could have been spreading it.
Part of that whole Bronze Age interaction sphere in Middle Asia.
Precisely. Goods, ideas, and apparently pathogens, too.
Were there other factors maybe making people more vulnerable back then?
Possibly. The sources mention a period of climate shift around this time. Droughts, changing rainfall. This could have pushed people into denser settlements, like cities, and also increased the need for long-distance travel and trade to get resources.
Okay, so more contact, more movement.
Right. And think about the traders themselves. Bioarchaeologist Charlotte Roberts points out they probably faced tough conditions, hard labor, long journeys, hot climate, maybe not always great nutrition or rest.
Which could weaken their immune systems.
Exactly, making them potentially more susceptible to infections they encountered along the way, like leprosy.
It sounds like a perfect storm, almost, for disease spread.
It could have been, yeah, a combination of environmental pressure, increased mobility, and physiological stress.
Now, you mentioned the pathogen. Is there work being done on the ancient bacteria itself?
Yes, they're doing ancient DNA testing that's ongoing. The hope is to see if maybe the Bronze Age version of the leprosy bacterium was actually more contagious than it is today, perhaps behaving a bit more like its relative, the tuberculosis bacterium.
Ah, that would be a major piece of the puzzle. But I saw a mention, a paleopathologist, Samuel Mark, raised a question about diagnosis right then.
hmm
Could it be confused with other diseases?
That's a standard and important consideration in paleopathology, yeah. Certain other diseases, TB, syphilis, leishmaniasis, even some cancers can leave marks on bone that sometimes look similar.
So how confident are the researchers it is leprosy?
They seem quite confident, largely because of that micro-CT evidence we talked about. Seeing the specific pattern of internal and external bone changes across multiple individuals, especially in those jaw fragments, gave them a strong basis for the leprosy diagnosis, distinguishing it from those other possibilities.
Okay, let's circle back to that micro-CT then. It sounds like a really powerful tool for this kind of work.
It really is, because in archaeology, you're often dealing with bones that are broken, mixed together. Maybe you only have a small piece. Traditionally, diagnosing leprosy often relies on seeing a pattern across the whole skeleton, hands, feet, face. Very hard with fragments.
But micro-CT gets around that.
To a large extent, yes. It lets you see these tiny microstructural changes within a single fragment, non-invasively. You can spot things like superiosteal new bone formation, that's new bone laid down under the outer skin of the bone, which is a key indicator of chronic infection like leprosy. It helps confirm the disease and rule out post-mortem damage.
Sounds indispensable. Is it widely available?
That's the catch. Micro-CT scanners are expensive, and you need specialized expertise to run them and interpret the data. It's not something every lab has access to. The researchers suggest more collaboration between institutions could help make the technology more widely used.
Makes sense. Any downsides? Does scanning affect the bone for other tests?
There's a brief mention of potential concerns about its impact on future ancient DNA analysis. Right now, there isn't strong evidence it causes problems, but with ancient samples being irreplaceable, caution is always advised.
Okay, so this is fascinating for understanding the past, but you hinted it might connect to the present day too. Modern medicine.
Yeah, surprisingly, or perhaps not so surprisingly, diagnosing leprosy today can still be tricky. Maybe up to 30% of cases don't show those classic textbook signs initially. Diagnosis can be delayed.
Really? Even now?
Even now. So looking at how the disease affected bone in detail, thousands of years ago, using something like micro-CT on these ancient jaws, it actually gives us clues.
How so? How can ancient bones help modern doctors?
Well, past attempts to use modern CT scans to help diagnose leprosy often focus on just measuring parts of the skull or jaw. But that approach hasn't been very reliable. This new research, based on the detailed paleopathology, suggests a different approach for radiologists reading CT scans today. Instead of just measuring, qualitatively look at the shape and texture changes in specific areas.
Okay, what specific areas?
Mainly the underside of the upper jaw and the palate. They suggest looking for subtle signs like erosion of that little spine at the bottom of the nose opening, a sort of U-shaped wearing away of the bone holding the front teeth, the edges around the nose hole losing their sharpness, signs of reactive bone growth, chronic inflammation on the palate.
Wow, very specific details.
Exactly. Things that show the chronic process. Now, CT scans are expensive, obviously, and standard X-rays just don't have the resolution to pick up these really subtle changes reliably. But for difficult cases where CT is used, this could offer new diagnostic clues.
That's incredible. Learning from 4,000-year-old bones to potentially improve diagnosis today.
It really connects the past and present. And zooming back out, this Oman discovery fundamentally shows leprosy moving along these Bronze Age trade routes, linking up different parts of Afro-Eurasia much earlier than we might have thought. The ongoing work at Dahwa, using all these different techniques, micro-CT, DNA, chemical analysis, it's all about understanding that Bronze Age connectivity and its impact on health.
It paints a picture of a surprisingly connected ancient world.
Definitely. And it feeds into evolutionary medicine, too. Studying diseases like leprosy over millennia without modern treatments interfering helps us understand their natural progression. That kind of knowledge is indirectly valuable for tackling modern challenges, emerging diseases or infections becoming resistant to our drugs.
Okay, so let's try and wrap this up. What are the absolute key things you should take away from this deep dive?
I'd say four main things. One, we now have the oldest confirmed leprosy outside South Asia, found in Bronze Age Oman. Big shift in the timeline. Two, ancient trade routes weren't just for goods. They were clearly pathways for spreading infectious diseases like leprosy. Three, micro-CT is a powerful tool for diagnosing diseases in ancient fragmented remains, and it revealed specific details about leprosy's effects on bone. And four, studying these ancient cases, these paleopathological findings, might actually help improve how we diagnose leprosy using CT scans in clinics today.
So what this means for you, listening in, is really thinking about how connected the world has always been. Even thousands of years ago, trade didn't just move objects, it moved microbes, shaping human health across continents. It kind of makes you wonder about our own hyper-connected world today, doesn't it? What unforeseen consequences might arise from our modern global interactions.
Yeah, and maybe a final thought to leave you with. If leprosy traveled these ancient routes, what else did? What other health stories are waiting to be uncovered in the archaeological record? And how can learning about those past challenges truly help us navigate the health landscape of today and tomorrow?